Today's lesson will deal with prime numbers. Really understanding prime numbers and how to get a prime factorization is really going to be important to us in some aspects of algebra here down the line. So here we go. Let's first off start by defining what a prime number is. A prime number is a number with exactly two factors. Sorry. Or that can be said this way, a number that has exactly two factors. Now, determining whether something has exactly two factors, and by the way, one of those factors is always going to be 1, and then the other one's always going to be the number itself. One thing we need to be able to determine is the number divisible by anything other than 1 in itself? And knowing some basic divisibility rules is really going to help here. So let's go through some divisibility tests. Obviously if a number is divisible by 2, then that number ends with an even digit. If a number is divisible by 3, then the sum of the numbers, the sum of the digits is divisible by 3. So for instance, 12 is divisible by 3 because 1 plus 2 is 3, and 3 is divisible by 3. A number is divisible by 5 if it ends with a 5 or a 0. Okay, now we can take these very simple divisibility tests and make up other ones. Like we can tell that a number is divisible by 4 if it's divisible by 2 twice. So if it's divisible by 2 and that result is divisible by 2, then the entire number is divisible by 4. A number is divisible by 6 if it's divisible by 2 and 3. So if it fits this criteria, it ends with an even digit, and the sum of its digits are divisible by 3. Well, 2 times 3 is 6, so the number must be divisible by 6. 8 is the number divisible by 2, and then the result of that divisible by 2, and then the result of that divisible by 2. If a number is divisible by 2 3 times, then it's divisible by 8, because 2 times 2 times 2 is 8. And if a number is divisible by 9, then the sum of its digits is divisible by 9. If a number is divisible by 9, then the sum of its digits are divisible by 9. And if a number is divisible by 10, then it ends in 0. Those are some other ones. You might want to write some of those down, so replay this if you need to hear those again. Okay, is 9 a prime or composite number? Draw rectangles using 9 squares to support your answer. Well, first of all, what is a composite number? Basically, a composite number is any counting number that is not a prime number. By the way, prime numbers should only be counting numbers too. So it's a composite number if it's a number composed of more than 2 factors. So, is 9 divisible by more than just 1 and 9? Yes, it is. 9 is divisible by 3 also. So that makes 9 composite. So, if we're going to draw rectangles to support this, let's make a rectangle that is 9. Need another one there. 9 by 1. And then we can make another rectangle that is 3 by 3. 3 times 3 is 9. And you can see that this uses 9 tiles. This uses 9 tiles. So if a number is prime, you should only be able to make a rectangle that is 1 high. Write the first 10 prime numbers. Okay, well, is 1 prime? No, it's not, because 1 only has 1 factor. Is 2 prime? Yes, it is. Is 3 prime? Yes, it's only divisible by 3 and 1. Is 4 prime? Well, all even numbers are divisible by 2, so 2 is actually the only even prime number. So we can ignore all even numbers at this point, but 5 is prime. It's only divisible by 5 and 1. 7 is only divisible by 7 and 1. 11, 13, 15, 17, 19, and 23. Does that give us 10? It does. So, which odd numbers did we skip? 9, because we already know that's divisible by 3. You know what? We got a mistake here. Let's fix this. 15 is not a prime number. It's divisible by 5. It's also divisible by 3. So we need one more here. How about we go with not 25. By the way, 21 is divisible by 3, so we can't use that. Not 25 because that's divisible by 5. Not 27, that's divisible by 3. 29, that would be the next one. All right, moving on. Glad I caught that. Draw a factor tree for 36. Make the first 2 branches 4 and 9. You guys have probably done factor trees before. Factor trees start with the number. You make 2 branches. In this case, they told us to make them 4 and 9. And then you break down 4 into factors. And you break down 9 into factors. Now, the reason I've circled the 2's and the 3's is because they are prime numbers. And once you get down to prime numbers, you can't break them up into any more factors. So here's the prime factorization of 36. 2 times 2 times 3 times 3. 2 times 2 times 3 times 3 will give you 36. Find the prime factors of 60 by dividing by prime numbers. This is a little bit different. You've probably never seen this method, but I actually like it a lot. What you do is start dividing 60 by prime numbers until you can't divide it by a prime number anymore. So 60 divided by 2 is 30. 30 divided by 2, another prime number, is 15. 15 is divisible by 3, which is 5. And at this point, we end up with a prime number, 5. So that means we're done. The prime factorization of 60 is 2 times 2 times 3 times 5. 2 times 2 is 4. 4 times 2 is 12. 12 times 5 is 60. That's the prime factorization. Let's write the prime factorization of each of these numbers. I like that division method. I use it. 25 is not divisible by 2. It's not divisible by 3. Those are the first 2 prime numbers. Is it divisible by 5? Yes. And then we end up with a prime number, so its prime factorization is 5 times 5. Okay, what about 100? Is that divisible by 2? Sure. 100 divided by 2 is 50. 50 divided by 2 is 25. Okay, it's not divisible by 2 anymore. Is it divisible by 3? No. Is it divisible by 5? Sure. And we end up with a prime number. So the prime factorization of 100 is 2 times 2 times 5 times 5. 16. Is that divisible by 2? Yes. Is 8 divisible by 2? Yes. Is 4 divisible by 2? Yes. And we end up with a prime number. So the prime factorization of 16 is 2 times 2 times 2 times 2. Choose a number to complete the statement and justify your choice. A multi-digit number might be prime if its last digit is blank. Well, if its last digit is 4, that would mean it's divisible by 2, so it wouldn't be prime. If its last digit is 5, that would mean it's divisible by 5, so it wouldn't be prime. If its last digit is 6, that's an even digit, so it would be divisible by 2, so that wouldn't be prime. 7. Yeah, not all numbers that end in 7 are prime, but it's got at least a possibility that it might be prime, so there we go. Choice D. And last thing, 6 squares can be arranged to form 2 different rectangles. Okay, we got a 6 by 1 rectangle and a 3 by 2 rectangle. The model illustrates that 6 is composite and not prime. Illustrate 12 is composite by sketching 3 different rectangles with 12 squares each. So 12 is composite. We're going to show that by making more than just a 12 by 1 rectangle. But I'm going to start there. Here's my 12 by 1 rectangle. Not the prettiest rectangle ever. Okay, 12 is also divisible by 2, so I'll make a 2 by 6 rectangle. And 12 is also divisible by 3, so I'll make a 3 by 4 rectangle. Okay. If you can ever make more than a rectangle that is just 1 unit high, then that means the number is composite. If the only rectangle you can make is one that is 1 unit high, that means it's a prime number. All right, that's it for today. Getting pretty close to our first test. Do lesson 10 tomorrow and then our first test. So good luck. See you tomorrow.